Hey guys, today we're taking a look at developing formulas for calculating or finding the length of the altitude in a two-dimensional polygon. Now remember, the altitude is another name for the height of that polygon, and it's often found by taking the perpendicular length or distance between two bases or a vertex of a figure and a base. So check out our website for some examples of what those altitudes may look like. Now, in order to calculate these, we are going to use some old familiar tricks. The Pythagorean Theorem, a squared plus b squared equals c squared, and our trig ratios. Remember, those are the sine, cosine, and tangent ratios. So let's take a look at our first example. In our first example, we want to find the area of this triangle by first finding the height of that triangle. So over here we see that we have a right triangle, and I'm given one angle and its adjacent leg. And I want to find the height of this triangle, which is my opposite leg. So because I want to find my opposite and I know my adjacent, that reminds me of my tangent ratio. So the tangent of 48 degrees is going to be equal to the relationship between the opposite leg, x, and the adjacent leg, which is 5. Now remember, we said we can set up this proportion and cross multiply. So this becomes x times 1, which is just going to be x, and that's going to be my opposite leg, and that's going to be equal to the tangent of 48 degrees. Oops, there goes my little calculator thing here messing up. And so we're going to have the tangent of 48 times 5. So we're going to put that in parentheses and then multiply it by 5. All right, so if you have your calculators ready, we are going to use our calculator to find that value. So we're simply going to type in 5 times the tangent of 48 degrees. Close our parentheses, and we see that that is equal to 5.55. So we'll round that to the nearest tenth, and that gives us 5.6. So our height of this triangle here is 5.6. And now we can go ahead and calculate the area, because we know our area formula is simply base times height divided by 2. So we have 5 and 5.6. Multiply to each other and then divide that by 2. So again, we'll let our calculator do the work here. That gives us 5 times 5.6. We'll divide that by 2, and that will give us the area of 14 square units. All right, let's take a look at another example. In this example here, we are given that we have an isosceles trapezoid, and we want to draw in our height, or the altitude, and find the height and then its area. So I am going to draw in this little dotted line here that goes from the vertex of this top point of my isosceles trapezoid perpendicular to the bottom base. And this is going to represent my height. Now I also know that if I were to draw in the same height over here on this side, I could do that, and it was going to be the exact same altitude length or height length. Now I'm going to do this because this is going to help me find that height. Keep in mind, this is an isosceles trapezoid, and what I've really just created is a rectangle. So if this base up here on the top is 16, then the base down here on the bottom is 16. However, I have a remaining amount that is equal on both sides. So if I take 16 away from 26, I'm left with 10, which means these little pieces of these side triangles have to be 5 units of measurement each. Now I can use Pythagorean Theorem to find the height. So if I were to take this triangle kind of out of context, what I have is a hypotenuse of 13, a base of 5, and I'm going to find the height by using Pythagorean Theorem. So we're going to say 5 squared plus h squared is equal to 13 squared. That gives me 25. Oops, actually that gives me a circle. That gives me 25 plus h squared is equal to 169. Now I'm going to subtract 25 from both sides, and when I do that, I'll have 169 minus 25, which is 144. My final step is to take the square root of both sides, and when I do that, the square root of 144 is going to be 12. So the height of my trapezoid is 12. All right, now I can proceed by finding the area, because I know my area for a trapezoid is going to be my height times the sum of the two bases, which are 16 and 26. And then that's all going to be divided by 2. All right, so we're going to let our calculator do the work here on this one. And we're going to type it in just as we see it done there. So 12 times 26 plus our 16, close our parentheses, and divide that by 2. And we'll get 252 meters squared. All right, in our next example here, we are asked to draw in our altitude for our triangle. So you can see we have kind of an acute triangle over here. We're given this angle of 44 degrees. So I'm going to draw in my altitude that comes from this vertex perpendicular to the other side. And there's my height of that triangle, also known as my altitude. And I can calculate that height now because what I'm looking at is I'm actually looking at a right triangle in which I know my hypotenuse and I want to find my opposite leg. So that reminds me of my sine ratio, which tells me the sine of an angle, in this case it's 44 degrees, is going to be equal to the opposite leg, which is my height, so I'm just going to call it opposite for right now, over my hypotenuse, which is 16.35. Okay, I'm going to create my proportion, and I'm going to cross multiply, and when I do that, I'm going to have 16.35. Every once in a while, it likes to give me a circle there. So 16.35 times the sine of 44 degrees. All right, time for that calculator again. Let's pull that guy up and see what we get when we take 16.35 and multiply that to our sine of 44 degrees. And that's going to give us 11.4. So we'll just round that to the nearest tenth. 11.4 is the height of my triangle. Okay, so once we get that height, now we're going to go calculate our area. Our area here is base times height. Now our base, remember, is this entire side that the altitude is perpendicular to. So we're going to take our 7.43. We're going to multiply it to our 11.4. And that's going to give us, and then we got to divide that by 2. So here we go. We're going to let our calculator do the work here. And we have our 7.43 times our 11.4. And then all that divided by 2. And we get our 42.3. All right, so the area here, 42.3 centimeters squared. And that's a little bit about developing the formulas for altitude of your triangles, parallelograms, and trapezoids.